Hey guys, so a lot of motion problems are going to have multiple parts. And what I want to do in this video is show you two examples as well as some techniques to make this more manageable. So let's get started. Alright, so like I said, multiple parts. What we want to do is draw a complete interval diagram and write one equation for each interval. For example, I'm going from A to B and then from B to C. So how many intervals are here? Some of you might be thinking 2, but it's actually 3. There's this one, B to C, and then there's the larger interval A to C. And the key thing here is that you need to write one equation for each, but when you write those equations, make sure that the variables you're using correspond to that interval. For example, let's write an equation for this interval here. Let's say that the average velocity between A and B is the equation for average velocity is delta x over delta t. But if I'm doing this for A and B, I have to make sure that I use delta x for A and B and delta t for A and B. Okay? So that's one thing. The other thing I want to talk about is the idea that if I'm going from A to B, this is my initial and this is my final. But if I'm going from B to C, B is my initial and C is my final. So this presents a potential problem because B is final velocity for the first interval and initial velocity for the second interval. And that's not a problem in itself. The problem is that if you have a long question with a lot of different variables, you might get confused. You might get caught up trying to remember that final velocity in one is the initial velocity of the other. So to avoid that, what I like to do is, let's say the speed at A, I just call that VA. I just call this VB, and I call this VC. Because guess what? VB is VB for the first half and the second half. It's the same number and it's the same letter. And I think that makes it easier. So let's do a problem. A car travels with a constant 50, so constant velocity, acceleration 0, for 10 seconds, and then a constant 30, acceleration is 0, for 600 meters. Let's draw the complete interval diagram. I have two intervals, so I do this. Technically, there's the third larger interval there, A, B, and C. Now I'm going to put all the information I have for these points. So here it says I travel with a constant velocity, so I can call this velocity between A and B. It's an average velocity of 50. And since I'm putting that for the entire interval, you should know that that's a constant velocity or average velocity for the whole interval, not the specific velocity at A or B, but sort of in between. The acceleration for A and B is 0. What else do I know? I know the time between A and B is 10. All right? For the second part, I know that the velocity between B and C is 30. So the acceleration between B and C is 0. And the delta x for B and C is 600. Okay, let me put units here. Meters per second, meters, these are all standard units, so we don't really have to worry about units. Cool, so that's the interval diagram. Are you going to get a question asking you to draw an interval diagram? No, that's just a way for you to visualize how this stuff works, but you should always be drawing the situation anyway. So we got that. What is the total distance traveled? Total distance. Now, notice that I have delta x's. That's displacement, but the question is asking for distance. Guess what? If you think that you're just moving to the right, which you are, so think about it in terms of you're just moving to the right, so it doesn't really matter. The difference between distance and displacement here, it doesn't really matter. So I'm just going to think of this as my delta x. Now it's the total distance, so it's delta x from A to C. And all you got to do is piece them together. If you move 10 and then you move 20, then obviously your delta x is just 30. So this is just the sum of delta x for AB and BC. In fact, the same thing happens with time. The total time from A to C is just the time from A to B plus the time from B to C. All right, so if I want my total delta x, I need to have those two other numbers. I don't know delta XA. I don't have this, sad face. But I have delta x BC, that's 600, okay? So to get this answer, I'm gonna go ahead and do this. Kind of organizing the work here. to get this answer, I'm going to need to get delta x AB. So let's go do that. Delta x AB belongs to the first interval. So how do I find a number in physics? You write an equation, you solve the equation. I'm in the first interval here, a to b, so I'm going to write an equation for this piece, right? The acceleration is 0, so there's only one equation you can write, which is that the average velocity is delta x over delta t. So if you're solving for delta x, then you just have that delta x is vt, okay? Notice I didn't write delta t, I just wrote a t. I didn't write v average, I just wrote v, and that's fine. You don't have to write all the little letters every single time. Okay, so to find delta x AB, here I'm going to be a little bit more precise. I'm going to write v AB and t AB. And I do have those two numbers. The velocity is 50 and the time is 10. So my delta x is just 500 meters. Now I can plug this here, and my total answer is 1100 meters, and that is part B. A and B are done. Now let's do C. What is the average velocity from start to end? Remember the definition of average velocity. Definition of average velocity is delta x over delta t. But here I want for the total motion from A to C, so I need delta x from A to C and delta t from A to C. I know my total delta x, it's 1100. But I need my total time. I don't have the total time. Once I know the total time, I'll have the final answer for this. Okay, so let's go find our total time. To find the total time is right here. I know the first time is 10 seconds, but I need the second time, okay? I need the second time. So let's find the time between B and C. How do you find a number in physics? You find an equation. So delta t BC belongs here, so I have to write an equation for that interval. And the only equation I can write, again, is that the average velocity is delta x over delta t. Here I'm looking for time, so if I move things around, I find that delta t is v over x. Okay? So if I want to find this, delta t BC is just the velocity between B and C, and the delta x between B and C. And the velocity between B and C, did I get that right? Nope, I got it backwards. It's actually x over v. X over v. Whoops, big mistake. Delta x over v BC. Cool, caught that on time. So delta x is going to be 600, and the velocity here is 30. So this is 20 seconds. So my second time is 20 seconds. So my total time from A to C is just the addition of my two times, and it is going to be 10 plus 20 equals 30. So I plug in 30 here, you divide 100 by 30, and you get, I have this here, 36.7. 36.7. And that is the answer to part C. Cool? So you work on each interval separately, and then you just piece everything together to find the total average velocity. All right, so let's do the next one now. I'm going to solve this one as well. The first one had no acceleration. This one will have acceleration, but they're both multiple parts. All right. So here it says you're driving at 30 meters per second when you see a traffic light turn yellow. So you immediately hit the brakes, causing the car to decelerate. This is a classic problem of reaction time. And the idea of reaction time is when you see something and you immediately react on it, it's not actually immediate. It takes a little bit of time, which is usually 0.7, for you to do something. It's the time that it takes for your brain to process information and for you to react to it. And the idea in these questions is that for those 0.7 seconds, you don't do anything, right? You're actually just moving at the same speed, and then you start decelerating. So it's kind of dangerous, but let's see. You're driving at 30 when you see. So the idea is that that first interval, that first 0.7 seconds, this first 0.7 seconds, you don't actually do anything, right? You're still sort of reacting to it. Therefore, this is a two-part problem. A to B is your reaction. And this is where stuff is actually happening, right? A to B to C. So you cause the car to decelerate at a constant 7. That's for the second piece. The first piece, you do nothing actually, right? You're just like reacting to it. So the acceleration for this piece is 0. The acceleration for this piece is 7, but it's negative, okay? Now, instead of writing A, B, and B, C, that could get kind of annoying. I could just call this interval 1, and I could call this interval 2 if I would like. So I can do T1 and A1, and then this is A2. Okay, so the velocity here at point A is 30, and we want to cause the car to stop, to brake until it stops. So I want VC to be 30 as well. Now notice that my acceleration is 0 for the first part. That means that my VB is, actually this is 0, sorry. That means my VB will be 30 as well. Because between A and B, you're just reacting to it. Your acceleration is 0, your velocity doesn't change, right? You keep moving at the same rate. Here, you're going to come to a stop eventually. So let's see what it says here. First question asks us to find how long you will travel in the 0.7 seconds that it took you to react. So basically, between A and B, I want to know what is your delta x. That's what that's asking. What is a delta x from A to B? All right? So obviously, A to B belong to the first interval. A to B is the first interval, so I'm going to write an equation for that first interval. And what equation can I write? The acceleration is 0, so the only equation that's relevant here is that the average velocity is delta x over delta t. And I'm looking for delta x, so that's what I'm going to do. I'm going to solve for delta x here, move stuff around. So it's vt for that interval. The velocity is 30. The time is 0.7. So if you multiply this, you get 21 meters. So you covered 21 meters in the time that it took you to even react. Okay, we got that. So then it says, once you start braking, how long in seconds does it take for you to stop? So once you start braking, how long does it take you to stop? Once you start braking means B. So how long does it take you to stop from there forward is the time from B to C. So part B is asking us, what is the delta t for that second interval? And how do you find the number? You write an equation. So I have to pick an equation. For this second part, the acceleration is not 0, so I can have as many as 4 equations to pick from, right? And they are up here. Oops, on the top of the page. Now remember, your professor may or may not allow you to use that 4th equation, okay? So hopefully we don't even need it anyway. So once you start braking, how long does it take? Let's list what I have, right? V initial in this case is, V initial is your VB, and it's 30. V final is your VC, and it is 0. I wrote a 20 here, not sure why. The acceleration is -7. And what else do I know? Delta t is what we're looking for. I already have 3. And so delta x is the 5th variable, is the ignored variable, the one that I don't want, I don't know, I just don't care about. The delta x variable, being the ignored one, tells us that I should use the first equation to solve this, because the first equation doesn't have delta x. Remember that, right? So v equals v initial plus at, and the final velocity is 0, the initial velocity is 30, the acceleration is -7 time, so I can solve this by leaving time alone. I can move the 30 to the left, it becomes negative. Then I divide both sides by 7, and I get that time is, I have it here, 4.29. So my time is 4.29 seconds. And that's the answer that we were looking for. Okay, so A, B, that's the time there. Now, part C is going to ask, what is your total stopping distance? So again, I'm just moving to the right. You can, in one direction, you can just think of distance as displacement. There's no difference between them in this one. So I can just say, what is my delta x from A to C? Okay? And obviously the delta x from A to C is going to be AB plus BC. Do I know AB? Yes, I know AB, but I need BC. Okay? So this is going to be delta x AC is going to be the first one plus the second one. I know the first one, 21 meters, but I need this guy here. And once I have that guy, I know the entire answer. Okay? So now let's find delta x BC. And guess what? Delta x BC is the only variable that I still don't know for that interval. I actually, at this point, I know 1, 2, 3, and I know the time now is 4.29. I know 4 out of 5, so it should be pretty easy to solve this. When you know 4 out of 5, you just need 3 out of 5, but if you know 4, you actually have 2 equations that you're going to be able to pick from. So hopefully we can pick the easiest one. And I'm just going to go with the third equation just because it's kind of an arbitrary selection, but just because it starts with delta x equals. You don't have to move things around. So delta x equals v initial t half at squared. So now all I got to do is plug in these numbers. The initial velocity here is the velocity at B, which is 30. The time that it takes between B and C, we already found it, is 4.29. This is half, the acceleration is -7, and then the time is 4.29 squared. And when you do all of this, I get 64.3 meters is my delta x B to C. Okay, but we're not done yet. You got to plug this in here. Okay, so 64.3. So my final answer is 85.3, and that is the total displacement from A to C, right? So once again, in these questions, you're going to break them into small pieces and then put it back together at the end. All right, that's it for this one.